Morning students, class 9. In the previous class, we have discussed to calculate the time by the simple pendulum. Might you have done the solved problems which is given. In these problems, simple formula will be used, that is t is equal to 2 pi under root L upon g. Simple formula will be for the calculation of time, t is equal to 2 pi under root L upon g, where t is the time period, L the length and g is the force of gravity. This may change, this may be asked to calculate, and the t, time period can be asked to calculate. Value of pi, either use 22/7 or 3.14. What the value is given, 3.14, that only we will use, or if it is given the numerical problem 22/7, that only we will use. That will be easy for the calculation. Understood? So we'll come to exercise numerical problems. Come to page number 25, where the numerical problems are given. Number 1. A simple pendulum oscillates 40 oscillations in 1 minute. Question number 1. 40 oscillations in 1 minute. Or you can write 40 oscillations in 60 seconds. 60 seconds. What they are? Frequency. Frequency means the oscillation made in 1 second. Oscillations made in 1 second. So what we write? Frequency is equals to oscillations made in 1 second. Yeah? So here how many oscillations are made? 40 oscillations are made. In how much time? So frequency will be number of oscillations over time taken. It will be better if you write the formula in words, or 40 oscillations in 60 seconds. 0 cancel, 2 times, 3 times, and when you will solve, it will come 0.666, or it can be rounded as 0.67 seconds per second, or hertz 0.67. Anything you can write, both are accepted. This was the part first, or A part. Now in the second part, there was the time period. Time period, we know that t is equals to 1 upon f, or time period is reciprocal of frequency. Time period is reciprocal of frequency. So we write 1 upon 2 by 3, or 40/60. So when we solve it, will come 1 by 1 into 3 by 2. It will give you 1.5 seconds. Time period is 1.5 seconds. What does it mean is that one complete oscillation is made in 1.5 seconds. This is the way how to solve the numerical problem. Yeah, number 1. Now question number 2. Note down this. Question number 2. Time period of a simple pendulum is 2 seconds. Here given time period is equals to 2 seconds. Time period 2 seconds. What is frequency? Simple. Frequency is asked. frequency question mark. So T is equals to 1 upon F or F is equal to 1 upon T. We can write 1 by 2 F or frequency is 0.5%. Please check answer. 0.5 per second. Now what is another information what he wants is what the name is given to such a pendulum. Say you write when pendulum takes 2 seconds to complete one oscillation, it is said to be seconds pendulum. Seconds pendulum. If a child writes second pendulum, then also it will be accepted. Or the meaning is when the time period of a pendulum is 2 seconds to complete one oscillation, it is said to be a seconds pendulum. Second numerical I have done. Third one, read the question carefully. Read question carefully. Question number 3. Second pendulum is taken to a place where acceleration due to gravity falls to 1/4. Means second pendulum means time period of this pendulum given as 2 seconds. It is given by the name because it is given as seconds pendulum. 2 seconds. It is taken to a place where the acceleration due to gravity falls to 1/4. The value of G at place G becomes G by 4. This is notable step. G by 4. How is the time period of simple pendulum affected? If at all, give reason. What will be the new time period? Initial time period T is equals to, we write here, initial time period of seconds pendulum. T they have given 2 seconds. T is equal to 2 pi under root L upon G. We can divide 2 here, it will become 1 is equals to pi under root L upon G. First case. Or squaring both sides, we can write squaring both sides. 1 is equals to pi square into L upon G. Where G is equals to second, where G is equals to G by 4, then what will be the new time period? Two pi under root L upon G by 4. See this. T is equals to 2 pi under root L upon G by 4. What we can write? t is equals to 2 pi L upon 1 into 4 upon G. This 4 will come up. Here if I write t by 2 or squaring both sides, it will become 4 pi square into 4L over G. Pi square, it will also be square only. Pi square L upon G, here 4 pi square, 4 into it can be written as 16 pi square L upon G. So check the time period will be double because time period will become 2 times. Please check, time period will become 2 times double because t is inversely proportional to the new time period will be 4G. Note down this. Note down this. Time period will become, new time period will be 4 times or 4 seconds. Question number, if any doubt in this, you search out, see every step and you search out if any doubt. This can be done another way also. Second way you can see, if you find it difficult, t is equals to 2 pi under root L upon G. Time period they are given 2. So second case t2 will be 2 pi under root L upon G by 4, 2 pi under root is 4L upon G. So this comparison will be easy for you, I think. Here it is 2 pi under root L upon G. Here it is 2 pi. This 4, when it will come outside, it will be 2 multiplied by 2 under root L upon G. So 4 pi under root L upon G. So this is 2 pi under root L upon G, it will be 4 pi under root L. Time period will become double. Time period will become double. New time period will be 4 seconds. Discard this part. You find it difficult, discard this part. This will be easy for you. This you. Clear? Discard this. See this numerical third. Algebraic it is. No numerical problem it is. It comes in the numerical, but it is algebraic, fully algebraic question. Clear? Case first. And this is case second. Question number third. Discard this part if you find it. This 2 pi into root L, it becomes 4 pi, so it will become double. You can show by this. Next you come to question number 4. Read question first. Note down the given values in your notebook. Question number 4. Find the length of second pendulum at a place where g is equal to 10 meter per second square. See, question number 4, we have to calculate the length, question mark. Question. Find the length of second pendulum. Second pendulum. Second pendulum. Time period is 2 seconds. This is understood. At a place where g, they have given value of g is equals to 10 meter per second square and pi 3.14. So again we have to use the same formula. Which formula? T is equal to 2 pi under root L upon G. T is equal to 2 pi under root L upon G. So solution from here, T is equals to 2 pi under root L upon G. Time period they have given. Time period they have given 2 seconds because of simple pendulum. 2 seconds. 2 value of pi also given into 3.14 under root L upon value we have substituted. Now 2 if you will divide, it will become 1. 2 by 2. 3.14 under root L upon 10. So cancel this 2, it will become 1. Now we got 1 is equals to 3.14 under root L upon 10. Here you see this under root we don't require. We don't require this under root, so it is better we squaring both sides. Squaring both sides, we get squaring both sides, we get 1 square, 1 only, 3.14 whole square into L upon 10. You got it? Why I have made it square? To remove this under root. So on multiplying this 3.14 into 3.14, manually we have to do that. Don't use calculator. 4, 4, 16, carry over 1, 4 with the 5, 4, 3 are 12. Cross. 4, 1, 3, double cross. 3, 4 are 12, 3 and 3, 3 are 9. 6, 9, 5, 7 and 9. Check once again. 16, carry over 1, 4 the 4, 5, 3, 4 the 12, correct. 4, 1, 3, 3, 4 the 12, 3, 4 the 12, carry over 1, 3 1 the 3 over 1, 4, don't be in a hurry, and 3 3 are 9, 6, 9, on this will 3 to 5, 4 3 are 7, on 1 8, 8, decimal 1 2 3 4, 1 2 3 4, 9.8596 into L divided by 10. So it will become 10 over, here it was 1, 10 upon 9.8596 is equals to L. More than 1, so it will become, just check, well, You have to divide this value. When you will divide, you will get L is equals to 1.04. 1.01442. This you have to do manually as I have shown. Understood? Manually as I have shown. Note down any doubt. Question number 5. Read problem question number 5 fast so that we can do fifth question. Compare the time periods of two pendulums of length 1 meter and 9 meter. See question number 5. T1 is equals to 2 pi under root L upon G, or T2 2 pi under root L upon G. Here they are given the length of the pendulums are 1 meter and 9 meter. So we substitute the values. T1 upon T2, 2 pi under root here length is 1 upon G, 2 pi under root L is 9 meter, 9 upon G, 2 pi cancel, and if I release I write T1 upon T2, it will become 1 by root G over, from 3 under root if I take 3 upon root G. So if I solve it, it will come 1 by root G into root G over 3. Root G cancel. T1 ratio T2 is equals to 1:3. Answer, please check. Now, question number 6. Fifth was very small question. Question number 6. Read question. Pendulum oscillates 2 oscillations in 5 seconds. 2 oscillations, 5 seconds. 1 oscillation, 5 by 2 seconds. So 1 oscillation is equal to time period. Time period is equal to 2.5 seconds. What does it mean? That it completes with 1 oscillation in 2.5 seconds. They have asked first part for time period. B. If G is 9.8, find its length. Now they have given G is equals to 9.8 meter per second square. This was the first part. Second part. And we have to calculate. So again we write T is equals to 2 pi under root L upon G. Time period 2.5. Time period 2.5 you use, and 2.5 is equals to 2 into value of pi if they have given. Just see the value of pi not given. 3.14. L upon 9.8. This value we can divide 2.5 divide by 2 into 3.14 is equals to under root L upon 9.8. Squaring both sides to remove this under root, it will become 2.5 into 2.5 over 2 into 2 into 3.14 into 3.14 is equals to L upon 9.8. So 9.8 cross multiplied, 2.5 into 2.5 multiplied by 9.8, wrong calculation, 2 into 2 into 3.14 into 3.14. This will be the required length. So first of all multiply this. If there is any cancellation, you cancel. Yeah. And for the length, when you will solve, you will get L is equals to 1.55 meter. This was our question number 6. Question number 7. Read question number 7 carefully. Time period of two simple pendulums at a place are a ratio of 2:1. What will be the ratio of their lengths? See what they have given. Time period of two simple pendulums at a place are a ratio of 2:1. See, T1 ratio T2 they have given 2:1. This is given. What is the ratio of their length? L1 ratio L2 we have to calculate. So first we will write T1 is equals to 2 pi under root L upon G over T2 is equals to 2 pi under root L upon G. T1 T2 ratio they already given. 2:1 is equals to 2 pi under root L upon G over 2 pi under root L upon G. So squaring both sides, this is cancelled. This will also cancel. Squaring both sides, it will become 4 upon 1 L upon G L1 L2 L1 L2 upon G. So G and G will be cancelled. 4 upon 1 is equals to L1 upon G into G upon L2. G and G will be cancelled. 4:1 is equal to L1, or you can write 4 upon 1 is equals to L1 upon L2. So therefore L1 ratio L2 is equals to 4:1. So class 9th we have done 1 to 7 questions I have done. All are single formula based, is equal to 2 pi into L upon G. 2 questions I left for your homework. If you won't be able to, you can call me on my personal number, or personal number you call. I will solve this in the next class. So thank you students. Go through it. Try these questions again in your copy. Write problems and you try to solve this. Thank you.